Text-only AI reads words. Multimodal AI reads the world. Imagine you upload a messy desk photo and ask, "Where is my USB drive?" The model answers, beside the keyboard, next to the coffee mug. That's the shift we're entering. This is Unit 4, Video 1. Today we're breaking down vision plus language systems from scratch. What they are, how they work, where they shine, and where they fail. And yes, we keep it practical. By the end, you'll know exactly what to build, what to trust, and what to verify. Why does this matter? Because language alone misses context. If I say, "That's a jaguar," do I mean the animal or the car? With an image, ambiguity collapses instantly. Vision language models combine text understanding with visual perception, enabling tasks like image captioning, visual question answering, OCR with reasoning, and grounded search. In short, they do not just generate fluent text. They generate text tied to evidence in pixels. Here is the core architecture. First, a vision encoder converts image patches into visual tokens. Second, a text encoder converts your prompt into language tokens. Third, a fusion transformer aligns both streams through cross-attention. Finally, the decoder generates an answer grounded in both modalities. The key engineering challenge is efficient token budgeting. Too many visual tokens, and latency explodes. Too few, and the model misses details. Now let's talk about clip-style learning. During training, the model sees image and caption pairs. Correct pairs are pulled closer in embedding space. Incorrect pairs are pushed apart. This contrastive objective creates a shared semantic map where image and language can meet. That's why you can do text-to-image retrieval, smart moderation, and relevance ranking at scale. Think of clip as building a universal dictionary between pixels and words. Where does this already work in real life? In education, students snap equations and ask for step-by-step explanations.in e-commerce. Users upload photos to find visually similar products.in productivity tools. Screenshots become searchable knowledge.in accessibility. Scene description helps users with low vision navigate daily tasks. The pattern is consistent. Visual evidence plus language reasoning creates better outcomes. Now the twist. Vision language systems can fail in dangerous ways. They can hallucinate visual details that are not in the image. They can underperform on underrepresented cultural contexts. They can expose privacy-sensitive information from screenshots. And OCR overlays can carry prompt injection attacks. So production systems need guardrails, confidence thresholds, refusal behavior, source highlighting, and human fallback for high-risk cases. Before shipping, use this 5-point checklist. 1. Data coverage across environments and demographics. Point 2. Human evaluation on hard edge cases. Point 3. Confidence thresholds with safe fallback. Point 4. Safety filters and red team stress testing. Point 5. Human handoff for high consequence decisions. That's your launch baseline for Vision Plus language. If this helped, subscribe and comment what we should build next: Visual Tutor, Document Copilot, or Accessibility Assistant.